On. Hey guys, what's going on? Chris back with you guys, and I've got Peter along with me today. I'm glad to have him on board because we decided we need to break down what NASA, ESA, all these other space agencies are doing to these photos, manipulating, because we've taken a lot of heat. And Pete, you'll understand that what I'm saying. We've taken a lot of heat. There's a lot of people, like they're naysayers. Oh, you guys are morons. You don't know what you're talking about. They're simply rocks. Well, we can back up what we're saying. We can actually back up. And guess what? We can not only back it up, but we're going to back it up with NASA, JPL, and we're going to show you guys just what these things are capable of. We're going to read these things to you and also give you the links. They'll be in the bottom of the video in the description. So you guys can read all of this, because we're not going to read every single word on each page. It'll take too long, and frankly, we'll probably want to hang ourselves. But anyway, so... there's many things we've talked about, whether manipulations, obfuscations. We just want to show people, and it's not about the doubters. That's not what we're doing the video for. We just want to make people understand what's really going on with these photos, and that they can get a better perception of what's going on and how easy it is to be fooled. And, that's what it comes down to, right?
And what we're trying to say is that the quality of the equipment that these guys are using in the rover, in the Curiosity rover, and in the satellites, the qualities of the cameras are top range. Yeah. These surpass anything that you'll be able to buy in the shops with regard to reproductive quality.
Absolutely. And, I've been saying this all along. In fact, we talked about the high-rise, and that it's a extremely, the camera's, it's unprecedented. And it even says it, and I'm going to read that to you guys in a minute. But I even said it jokingly, I can get in a fetal position and fit right in this camera. And it's not a lie. I'm not a big guy. I'm only like 5'8", 5'8.5", but I can fit in that camera with ease. So we're going to go ahead and show you that right now, just to give you guys an idea. I'm going to read some small excerpts from it, and we'll just kind of go from there. So here we go right here, and this is the high-rise camera, and you can see it right here, the high-rise, high-resolution imaging science experiment. And you guys have, you guys can see this yourselves, and anything that Peter he wants to show us, I'll go ahead and stop, and he'll share his screen, and he'll be able to convey what he wants to convey as well. So we've got the high-rise, or the high-resolution imaging science experiment, has photographed hundreds of targeted swaths of Mars surface in unprecedented detail. The camera operates in visible wavelengths the same as human eyes. Now, keep in mind, guys, I keep saying, people argue with me and say, well, you don't understand what you're talking about because, it takes them in different filters, different, light ranges and filters and so on, different frequencies of light and everything else. Well, it just goes to show you right here, the same as the human eyes, as well as different wavelengths. But with a telescopic lens that produces images at resolutions never before seen, and planetary exploration missions. These high-resolution images, now get this, enable scientists to distinguish 1 meter size, about 3-foot size objects on Mars, and to study the morphology, surface structure, in a much more comprehensive manner than ever before. Okay. High-rise also makes observations near infrared wavelengths to obtain information on the mineral groups present. From an altitude that varies from 200 to 400 kilometers, about 125 to 250 miles above Mars, High-rise acquires surface images containing individual basketball size 30 to 60 centimeters or 1 to 2 feet wide pixel elements, allowing surface features 4 to 8 feet across to be resolved. These new high-resolution images are providing unprecedented views of layered materials, gullies, channels, and other science targets, in addition to characterizing possible future landing sites. And it just goes on to say Mars Global Surveyor, Mars Odyssey, so on and so forth. Now, what do you think about that, Pete?
Well, to me, this means to say that if they wanted to actually photograph the Curiosity rover, they could actually photograph it, and we're able to see quite clearly that it was the Curiosity rover, probably looking as big as a car, something like that, from overhead. And well, I mean, you've mentioned before, Chris, apparently that the NASA technicians say that these high-res cameras are so accurate in the detail that they can see the actual tire treads
Yeah, the wheel marks themselves.
The wheel marks that the Curiosity rover is making in sand. If this is the case, why haven't we seen an image of the rover where we can clearly see that it is the vehicle and not just a tiny dot on the surface?
Right. Because I have never seen one yet. I've never seen it up close.
It's never been shown.
And I showed the video where the engineer, and talked about the engineer, how he actually said, because it has no odometer, no GPS, which I find that hard to believe, but it says it doesn't have any way of knowing, it doesn't have an odometer kind of thing. So what they do is they just zoom in, and I just read it, the high-rise camera, 3 to 4 foot in width, and the rover's bigger than that. It's like a 10 foot by 9, I think.
Yeah,
so it's the size of a small SUV. They said they can literally see these fins, every one of them that are on the wheel. They can see exactly how far that thing's going. And when it makes one revolution, and it says JPL in Morse code on that stretch of band across the wheel, they know how many feet that thing's going on per revolution and per fin on the wheel. Okay. Has anybody ever seen these? I've never seen it.
Yeah, so yeah, you've got to, guys. You've seriously got to start, and girls. Sorry, not being there.
Yeah, well, yeah.
We've got to start asking, why is it NASA are not showing any of these close-up images of the rover on the surface? Why do we only see a tiny little dot shot from miles away?
Yeah, exactly right.
And you know, I would throw a guess out that the reason why they're not showing it is because we'd see far much more than we're supposed to see.
Yeah.
We'd start seeing what's actually on the surface of Mars, rather than this stupid images that have been showing it to be a desert. It's not a desert. I think it's quite a vibrant planet, probably.
Well, and the other thing is too, I'm going to read some of the specs about these cameras. More importantly, the Molly cam as well as the mass cam. And when you people see this, you'll know. I mean, you just, the mind will be blown. It's as simple as that. I mean, you know, I've been saying this all along. There's no way they're going to have a high-rise camera that has the capabilities this thing does, and then put some subpar camera on the vehicles, on the MSL and Opportunity, which is still running, and Spirit is a dead stick. But they're not going to do this, guys. They're simply not going to do it. They're going to put top-notch, best of the best, and far above what we're the regular civilians use.
Definitely.
And they're specially designed. These are not like something you can run into Walmart and get one, like a GoPro. It surpasses that. It makes them look stupid. I mean, so let's have a look. Unless you want to show something first, because I can go to the next page.
No, we'll go. Okay. Yeah, okay. I think we'll follow this on. Yeah.
Okay. Let me hit the next page. I don't know if you're seeing this either. Are you? When I do this, go to these pages. Probably not.
No, because you're not sharing. But I'm showing them on my own as well.
Okay. So now let's jump over to the Mars hand lens imager, or the Marley. Let me see here. And it shows, this is funny, because I almost died. Molly will provide Earthbound scientists with close-up views of minerals, textures, and structures in Martian rocks and the surface layer of rocky debris and dust. The self-focusing, roughly 4 centimeter wide, or 1.5 inch wide camera will take color images and features as small as 12.5 micrometers, or micrometers, depending on how you want to break it down, smaller than the diameter of a human hair. Okay, Molly carries both white light sources, similar to the light from a flashlight, and ultraviolet light sources, similar to the light of a tanning lamp, making the imager functional both day and night. I think we've seen a few night vision ones, but not a whole lot. The ultraviolet light will be used to induce fluorescence to help detect carbonate and evaporite minerals, both of which indicate that water helped shape the landscape on Mars. All right, now let me jump down here. I'm going to go to the next page here. This is, I believe, also. Now, this is the imager here, and I'm going to show you. Here's the Molly right here. It shows, Pete, you won't be able to see this, but you'll see this later on. But this is the actual imager. This is what's funny. In fact, let me do this because you haven't seen it. I'm going to go ahead and share this with you so you can see this as well. So This is the actual, you can look right here to the right. This is the rat, or the rock abrasion tool, and you can see these steel brushes. But here's the camera itself. Now, it flips up and down. This thing flips from, well, I can't do it that way, but it'll come straight up and flop over, because you can see the hinges right here, and it's got, like, wires going to the motor. Here's the funny part. This is the lens. So, check this out. The left eye of the mass cam, I want to get right to where it shows it. Well, I'll just read the thing. The left eye of the mass camera, or the mass cam on NASA's Mars, it's just showing it's actually using this to take the picture of the Molly. Is one of the tools on the turret at the end of the rover's robotic arm, which I just showed you. When this image was taken, the arm had raised to the turret and to about the same height as the camera on the mast. The mast cam's left eye has a 34mm focal length lens. Okay. The image shows that Molly has a thin film of coating of Martian dust on it. This dust accumulated during Curiosity's final descent to the Martian surface. As the Mars Science Laboratory spacecraft descent stage, or sky crane, engines were disrupting the surface nearby, which means it's just blowing up the dust. Now, this is what's funny. The reddish circle near the center of the mass cam, Sol 37 image, is the window to Molly's dust cover. Okay. With a diameter of a little less than a soda can's diameter, inside the lens, each of the 9 glass lens elements and the front sapphire window are bonded or cemented in place by the red-colored silicone RTV, which is, room temperature vulcanizing material. And a lot of people, anybody who works on engines, know what RTV is. This is a space-qualified glue that holds the lens elements in place. When the Molly is viewed from certain angles, this material gives one of the impression the inside of the lens is red. Now, is it possible they're keeping this thing closed and this is what it's seeing through? This is the reason why we're seeing a lot of red images. All they got to do is flip it up and over, and guess what? Crystal clear, or they can make it black and white, color, whatever it is that they want to do. Now, keep in mind, see if I can go to this one here. This is what's funny, and people don't realize this. Molly images can be acquired at working distances between 20.5 millimeters and infinity. Okay, permitting acquisition of close-up views with a pixel scale spatial resolution as high as 13.9 microns per pixel, as well as a selection of context views as greater working distances. Owing as likely uncertainties in robotic arm replacement, the very highest resolution images might be challenging to obtain on Mars. We expect to learn more during testing the arm replacement capabilities prior to launch. Now, keep in mind, this has all been done. This is information prior to the launch of Curiosity, or the rocket bringing Curiosity. Now, if you look, it says the figure below shows an example image acquired by the flight Molly during pre-delivery testing. So that means here on Earth. The ability to focus at infinity, combined with the location of the instrument on the MSL robotic arm, also permits imaging of some areas that are inaccessible to the other cameras on the MSL. Because obviously, if they could pick up the arm, guess what? They could see over boulders, whatever they need to see, and, including in-focus views under the rover, or because the robotic arm can be raised to stand higher above the ground than the remote sensing mast, or the RSM, from the vantage point higher above the surface that of the other cameras on the RSM. Okay, so what do you think so far, Pete?
Well, I mean, it's telling me again that the equipment that they're using on this particular on the rover, the cameras that they're using are really dynamic instruments, which will give the clearest resolution of photographs that have ever been really interesting. Let me just see where we are with this.
Yeah, we just had a small hiccup in this video, so I'm gonna have to learn how to use the movie maker type thing, because I don't usually typically use that. But the cameras on these things they're just insane. I mean, the Molly cam alone, because it can do up to millimeters, up to infinity. That's a key word, because the other things we're going to go on to as far as the features that this thing's capable of is just like mind-blowing. And yeah, so...
Yeah, the blurb that's put out by NASA says that the FFL mass cams we use are the eyes of the investigation, but they're not identical. They're built as a pair, but they're not identical. They've got different functions.
Right.
One camera, referred to as the mass camera, the mass cam, has a 34mm focal length, f8 lens that illuminates a 15
degree square, yeah.
inches square field of vision, field of view. 1200 by 1200 pixels on a 1600 by 1200 pixel detector. The other camera, the mass cam, has 100mm focal length. And what people need to realize is that these are telephoto cameras too.
Oh yeah.
They're not fixed. So in other words, they can photograph an object which is miles away virtually.
Yeah.
And the focal distance of one of them is to infinity. So
yeah, I mean, these things are basically like a miniature telescope in a can.
Yeah, that's it. That's it. Exactly.
So, you know, once you look at these things, and here's the other thing too. Let me see if I can figure this, find this where this was at. We look at this picture here. If you go down to the bottom of that, you can see this here. It says 2 mass cam 100 images. So it's the 100. Let me see. Let me go back here. It should be this one here. It should be right here. The mass cam on the right, the 100, and then there's the 34 on the left. Okay, look, that's the one they're talking about. Both taken with the Bayer color filters. Left image shows the single image RGB capability. Right image shows the uniform spectral response in the infrared as viewed by the Bayer filters. Okay, so now this is what really makes you start to wonder. Because if you see the ground like this, you see the way that looks all mushy and looks like crap, is it possible we're seeing actually flat ground in some of these photos, but we're not really seeing it per se? Also, notice on the left-hand side of the picture, what does it say back there? 17 kilometers. That's 10.5 miles. So think of this a minute, people. If you think about it, okay, 10.5 miles, Jesus. So what are they looking at? Are we looking at something really up close? Are we looking at something very far away? This is the reason why people have to be careful when they're looking at things in these videos. You've got to be really careful because what you think you're seeing, you're not. Or maybe you dismiss it and it turns out to be something. Who knows? Yeah.
And that's a really salient point, because you've got to try and figure out whether the image that you're looking at is one that's been shot on a telephoto setup. In other words, it's some great distance away, but it's a close-up view from some great distance away, or whether it's been shot relatively near to the rover itself. And unfortunately, NASA are not publishing this information on the photographs that they publish. So it's guesswork.
Well,
because they're not, first of all, they're not putting a scale on the individual images, and they're not putting the distance away from where the camera was when the photograph was taken.
Absolutely. I mean,
I mean, with regard to the technical capabilities of these cameras too. I mean, it says here each camera has an 8 GB internal buffer.
Yep.
In other words, it's not 2 MB or 6 MB. This is 8 GB internal buffer.
Yep. Absolutely.
And it permits it to store over 5,500 raw images. You know, so these aren't toys.
No. No,
and anybody who thinks, and anybody who is saying, "Oh, you know, these are crappy low range instruments," no, these are like highly sophisticated telescopes which can zoom in and take crystal clear photographs of just about anything which is in the vicinity of the rover.
Oh yeah. Well, here's another thing too. I'm going to scroll down here into that same page. Go underneath that graph. And underneath those, well, just above them 2 photos I just showed with the infrared as well as the color. Mass cam hardware and internal processing permit a wide range of optional flexibility. Each camera is capable of acquiring images at very high frame rates compared to previous missions, including 720p high-definition video or 1280 by 720 pixels at 10 frames per second and full science frames at somewhat greater than 5 frames per second. The full range of focus requires 45 to 60 seconds, which is fine because this thing's doing it all by itself. But autofocus around a predicted focus point can be accomplished much faster. Changes to consecutive filters positions take 5 to 8 seconds. Well, if you think about it, when you get your own regular camera, you're just like, it might take like a second or two, but okay, so 5 to 8 seconds depending on, It takes between 30 and 45 seconds to rotate the filter wheel, which is built into the camera, and into both mass cams, so the 34 and the 100. Wheel a full 360-degree mosaic acquisition is paced by the time it takes the RSM to move and from motion-induced vibration to settle. So in other words, yeah, you're going to feel it. The motor's going to be moving. It's going to vibrate the mast, and you're going to have that little bit of a vibration. So that's the reason why it takes as long as it does. The cameras included auto and command focus capability and auto and commanded exposure control. Radiometric accuracy is, 10 to 15%, and precision is 5 to 8%. Exposure times are expected to vary from a few tens of milliseconds to a couple of hundred milliseconds, depending on the bandpass filter and the desired signal-to-noise ratio. So yeah, you guys get an idea. This thing is like insane. This is not some little toy. This is like ungodly. So when you think, again, when you look in this left photo, and I'll go ahead and click in a little bit so people can see what I'm talking about. When you see like right here up in your face 15 meters and you look in the back 17 kilometers, whoa. So what are you seeing in these photos, guys? Is it possible then what you're seeing or you think you see is actually a lot farther away, a lot closer? And I'm going to demonstrate this in a minute, but I want to see something. I want you guys to see what's even crazier. I've talked about a lot of these photos and the way this thing, I use the term, they're layering. I'll go back to the regular screen here so we can see Pete as well. I've said this multiple times. I said they're masking the photos. You've said this as well. I said that what they're doing is they're dropping like a photo on top of the actual photo. And I've called it layering. They're layering these photos, so on and so forth. Well, I just found this information, and I'm going to read it to you now because this is not a joke, man. This is the real deal here. So if you go to the MSL Science Corner, that should be the top. That should be your tab there, and you can read along with this too, Pete. I'm going to scroll down to this because it has image resolution. It tells you everything about it. But let me check this out. Onboard focus stacking. Now I'm going to go ahead and jump in here a little bit. Depending on the working distance.
Hold on, Chris. Which did you say to go to?
The MSL Science Corner tab. It should say Maz. It should be the. I'm trying to remember if this was the
Science Corner Home.
Yeah, it says mine. That's for the Molly. And when you scroll down past that picture, it shows like the rock up close, and it'll show you implementation, color, and then it breaks it down to each thing. But when you get onto that, it says, depending on the working distance and the target's surface relief, a close focus view of a geologic target might not be in focus over an entire image. For these cases, Molly can be commanded to acquire a series of images taken up to 8 to focus positions that bracket the location of best focus. Molly can then, check this out, Molly can then be commanded to use onboard software to merge them into a single best focus image. Focus plane merge or Z-stack. The Molly focus stacking algorithm also produces a range map of target, providing a measure of target's microtopography. Okay, now to me, let me jump back to Pete here. To me, think about this. It can take up to 8 photos. And if you go on and read this, it actually says that it can also, not only can the rover do this, now let's backtrack a little bit. I find it a little bit hard to believe. Now, I talk about this camera a lot. This is just a sleazy little Polaroid 8 megapixel. Nothing fancy, kind of a toy. Well, compared to this thing. compared to the Molly or any of the cameras on that. But what's funny about it is I'm going, okay, when I take a picture of something, now if I'm up real close to a rock, obviously the background is going to become what? Non-focused. It's going to be non-focused unless, of course, I go like this. I look above the rock and take a picture of the background. What's going to happen to the object in the front? It's going to become out of focus. Okay, so if they've got the camera completely focused on a particular area they want to look at, why would they give a shit whether the rest of it's focused? Why would they care? But okay, let's accept that. Let's go with that. It could take up to 8 photos. So now it goes, okay, normal photo, takes another photo. Okay, now it's refocused itself. So now the outer edges are now clear. And now, oh, wait a minute, the center's not clear. So they refocus and take another snapshot. But isn't this kind of strange how they could take multiple layers? You got the original. Okay, that one's not completely focused. Let's take about 7 or 8 more. Maybe 4, 6, whatever. Isn't it possible? Now, they're going to take these and they get them sent to Earth, of course. They can layer each of these photos. You got the original photo, then you got layered photos. Now, take that layered photo. Okay, there's something over here in this part of the picture that needs to be taken out. Let's say it's this object here, which is what I got in my hand, is a little MP3 player. Okay, that's in the dirt. We don't want them to see that. That's in the normal photo. That's in the regular photo. Now, if we take another photo that's identical to the original, but now maybe we take our rock mimicking software and we put it over said object. Now the next layer has got to do with something else over here on the left side of the picture. They want to take that out. So what do? They put like this another rock mimicking software, or they just do their magic on it, their manipulation or whatever they want to do. And guess what? So now this is the reason why you can burn through parts of these photos and parts of them you cannot. This is the reason, because what you can't burn out is the actual photo. The layered ones are the ones you can burn through. This is the reason why like I said, I can go like this and burn through a lot of these areas, and people go, well, you're just burning the photo. Well, yes, I am. I'm burning through the layer of garbage trying to get to the actual original photo. And that's what I've been trying to convey to everybody. But now I just read this, and I'm going to give you guys these links. You guys can check this all out yourself. I just think it's insane the way they're doing these things and how easy it is for them to manipulate a photo. I've got some other ones too. Now, I'll let you go ahead and respond to that too, Pete. What do you think about that?
Well, I think it's high time that when people look at our videos and start pulling to bits what we've been doing or trying to sort of analyze from these photographs, from what's in them, instead of them getting on and bitching to us, it's about time they got in touch with NASA after seeing the type of equipment that they're using and saying, why are we being perpetrated with this rubbish that's being published as photographs from Mars? We're only trying, Chris and I are only trying to work through the garbage which is in these photographs to try and get some sense of what it might have been featured in the original photograph.